Japan managed to build one of the largest coastal defense systems on Earth. It is an enormous 400-kilometer tsunami wall that is strong enough to face the ocean's most violent forces. But how was this colossal barrier built? And is it truly that strong to shield the nation from future mega-tsunamis? But before we dive deep into it, make sure to subscribe to our channel for more interesting engineering breakdown videos. Why Japan needed a tsunami Great Wall? The first question that comes to mind is, why does Japan even need a tsunami Great Wall? In 2011, the world witnessed a disaster that was so devastating that it permanently changed Japan's entire approach towards coastal protection. Entire towns vanished under the towering waves coming from the sea. Millions of tons of water tore through neighborhoods where people had lived peacefully for generations. Existing coastal defenses, which were considered totally reliable, were destroyed in just a few seconds. Japan already knew that it stood on one of the most dangerous tectonic intersections on the planet. 4 enormous plates press, grind, and slip beneath the islands, producing more than 500 noticeable earthquakes every single year. But the event that hit the Tohoku region in 2011 was beyond anything that modern Japan had ever faced. When the earthquake ruptured a 300-mile boundary deep beneath the Pacific Ocean, the entire seafloor was shifted upward. That sudden uplift displaced an unimaginable quantity of water. The wave that followed this surge toward the coast had a height that crumbled every record, every seawall, every model that was built at that time. The consequences of this event were catastrophic. Thousands of lives were lost, entire transportation networks were wiped out, and one of the most severe nuclear emergencies in history occurred at that time. Japan didn't just take it as a disaster, they took it as a warning. Japan realized that relying solely on evacuation drills and the old traditional seawall was no longer enough. They needed a new defense system, like something unmatched in scale, strength, and engineering precision. Something that could stop, or at least slow down, the waves that act more like liquid mountains. And that's how the planning to build a 400-kilometer tsunami wall, which stretches across Japan's northeastern coastline, began. This structure was so immense that many people at first thought that it could not even be built. How engineers designed a wall strong enough to fight the Pacific. Scientists and engineers spent years analyzing the physics of these mega-tsunamis long before the construction crew could even start the construction. At first, they needed to understand exactly how water behaved when it gained height, momentum, and speed across the deep regions and the shallow regions of the sea. They studied the pressure that was applied to the walls, the turbulence that was created at different angles, and how long a barrier could withstand direct impact before falling. This whole process started in laboratories where the scale models of coastlines were used inside massive wave tanks. Engineers recreated the same waves with the same height, surge, and turbulence as they were in the 2011 tsunami, and then they even pushed these models beyond those limits. It became clear after testing dozens of geometries, adjusted thicknesses, slopes, and reinforcements that this wall needed a distinct shape, which was broad, heavy, and deeply anchored. They were not trying to build another thin vertical structure, but a fortress this time. The final design of this wall had 3 critical features. First of all, its height was roughly about 14 to 15 meters. Secondly, its foundations were driven 20 to 25 meters deep to prevent any kind of sliding or toppling. And thirdly, reinforcement, which was a dense steel core surrounded by high-strength concrete. This was not just another wall defense. It was a multi-layered system that was engineered to endure violent impacts, survive erosion, and stay stable even if it was partially overtopped. Japan only approved the full-scale build when the laboratory tests successfully proved that the structure could handle extreme conditions. Mapping the 400-kilometer route. After finalizing the design of the wall, choosing the exact route was also as challenging as the design of the wall itself. Japan's coastline is jagged and broken into coves. It has harbors, cliffs, and low-lying plains. The Tohoku region alone has dozens of small towns where fishing is not considered just an occupation, but it's actually the core of the local economy. If the wall is built here, and the people in these towns cannot do fishing, their local economy will collapse. So engineers needed a line that was continuous enough to protect communities while still respecting ports, fishing routes, and geographic constraints. The final chosen route stretched through Aomori, Iwate, Miyagi, and Fukushima, the regions that were hit hardest in the 2011 tsunami. This made this defense system the most expensive and unified coastal project in Japan's entire history. Preparing the land, stabilizing the weakest ground. The nature of the Tohoku coastline itself was a huge challenge in the construction of this wall. Much of it consists of soft soil, sand layers, and sediment deposited over the past centuries. Heavy structures, like this wall, usually sink, crack, or tilt on such ground, unless they are reinforced. Workers had to perform deep drilling to map every layer of soil beneath the coastline before the construction could even begin. This procedure was like performing a medical scan, which would reveal which sections were weak, which were stable, and which sections required major reinforcement. In the sections where the ground was too soft to hold the wall, engineers drove steel or concrete piles deep into the stable layers and then added compacted gravel to form a dense foundation. This was used to reinforce the surface layers with additional soil mixing techniques. Excavation and foundation construction. Construction crews worked days and nights to dig enormous foundation trenches across hundreds of kilometers. In some locations, these pits went more than 20 meters deep, which is far below sea level. Temporary retaining structures, like steel sheet piles and cofferdams, were built to keep seawater from flooding the site. Once these pits were ready, engineers started reinforcing them with the help of base slabs of high-density concrete, heavy steel reinforcement cages, and massive foundation blocks that are designed to resist horizontal forces. This wall simply could not survive the Pacific Ocean's power without this enormous foot. If you're enjoying this video, subscribe to our channel for more of Japan's infrastructure deep dive videos. Building the wall, a block-by-block mega construction effort. After having foundations in the right place, crews finally started constructing the towering concrete wall. This process was repeated hundreds of times along the coastline to form a continuous interlocked chain of reinforced blocks. This whole process followed a strict sequence of assembling rubber cages at first, which were shaped according to the optimized lab design. Then the framework was installed to create the mold for each section, and after that, high-strength concrete was pumped in layer by layer. Every block of this wall was built with the kind of precision that is usually reserved for skyscrapers. Coastal conditions required every joint to be perfectly aligned to avoid any weak spots. Wave energy breakers, the armor that protects the wall. The wall itself was not the only defense. Engineers added layers of wave-dissipating structures around the base, like tetrapods, dolo blocks, and energy-absorbing concrete units. These oddly shaped interlocking blocks could disrupt wave motion and break up kinetic energy even before the water reaches the wall. All these things were not some aesthetic choices, but they were actually all designed precisely to counter tsunami waves based on the fluid dynamics research conducted by engineers. Integrating the tsunami wall with local communities. The engineers had to integrate the tsunami wall with local communities who are dependent on the occupation of fishing to make sure that their local economies do not collapse. For this reason, on the landward side, engineers built various drainage channels, roads or pedestrian paths, maintenance walkways, and emergency signage and ladders. This project not only protected the coastline, but also modified it, designing the tsunami gates for busy ports. Another one of the most challenging aspects of this project was protecting harbors where ships must constantly enter and exit. Blocking these with permanent walls was impossible, so Japanese engineers came up with a solution that is worthy of a science fiction movie. They built top-down vertical tsunami gates with massive steel panels that are suspended between concrete towers. When a warning is issued, the gate drops like a guillotine and forms a solid vertical barrier. They also built rising seafloor gates. These gates lie flat on the seafloor, but when they are activated, hydraulic systems lift them upward, forming a watertight shield. The completed sea wall, what Japan achieved. Now, if you are wondering what Japan has achieved by completing this seawall, the answer is that by the end of this project, Japan had constructed 400 kilometers of a continuous defense wall, which cost more than $12 billion in infrastructure, and has thousands of separately engineered segments with a unified system that is protecting millions of people. This was the largest coastal defense system ever built in the country. Computer simulations of this defense system now show that the wall can reduce tsunami impact by 30 to 50%. This is often the difference between reaching higher ground in time and being overtaken by the wave. This means that this wall could help people leave the targeted place and save their lives before the tsunami reaches them. The wall does not eliminate the risk, but it does buy life-saving minutes. Beyond the wall, Japan's undersea tunnel engineering. Just when you think Japan's ocean engineering can't get more extreme than this, you get to discover the underwater tunnel projects that are built in environments that are even more hostile than the open coastline. Undersea tunnels require watertight segments, perfect alignment, and structural systems that are capable of surviving constant pressure from above. For this project, engineers started surveying the seabed by drilling cores using sonar technology and mapping out the layers of rock, silt, and clay. Once all these tunnel segments are connected, engineers will seal the joints with watertight gaskets. Then they will secure the structure with gravel and sand, and then further reinforce it to withstand decades of ocean pressure. Inside these tunnels, sensors will be constantly monitoring vibrations, temperature, humidity, and even microscopic shifts. These tunnels do require constant maintenance, but they will allow regions across Japan to stay connected no matter what the weather or sea conditions are. Like the tsunami wall, these tunnels are a reminder that Japan does not shy away from nature's power, but it actually has the guts to confront it head-on. Japan's 400-kilometer tsunami wall still stands as a monumental symbol of engineering and resilience. And it serves as a barrier built not just from concrete, but from lessons learned through unimaginable tragedy. Don't forget to subscribe to our channel for more deep dives into the world's most extraordinary mega projects.